So graphene is a single atomic plane of graphite. We've been studying a lot of different properties of graphene, and at one point we decided to make it freestanding. We figured out what was happening is the membrane is kind of shaking around, the atoms are shaking around and vibrating, but then every now and then this local, let's say convex section of the membrane would flip its curvature over and become concave. If we place a charge on that ripple and it moves suddenly near a grounded conducting electrode, charge will flow in that conducting electrode basically to screen the charge that's moving toward it. If we had another electrode above it, when it flipped back, then the charge would flow, say in a circuit, up to this thing here. And the size of the samples that we look at are 10 microns by 10 microns, which is pretty small because about 20,000 of those could fit on the head of a pin. But one of these 10 micron by 10 micron areas could produce 10 microwatts of power continuously. So wouldn't that be great if you had this, powering your watch, for example? You would never have to replace the batteries. I like to think about the possibility of anyhow. Some people have, like say, pacemakers or mechanical devices as bioimplants. And if you could have a power source that you didn't have to replace the battery for, it's basically a battery alternative. I guess that's the key thing. If you could have a battery alternative that you didn't have to go and replace it, imagine, all the things you could do.